Alright guys, today we're going to crush it and destroy everything. As you've seen from the title of this video, I'll be explaining my process for creating realistic destruction in Unreal using Fracture and Niagara. Let's go! I'm starting by building a scene from scratch to focus initially on the fracture itself. Here I'm using the mech available for free in the Epic Rigs content from the marketplace. For the main part, which is the ground we'll destroy, I'm staying in Unreal and using our wonderful little plugin, the Modeling Mod. I'm going with a narrow but long broad here, and then I use materials and props directly from Bridge. We're dressing up our scene right from the start, no slacking here. Since version 5.2, I believe, the automatic assignment of the inner material for the geometry collection used in Fracture is no longer functional. We now have to manually set it up, otherwise we won't be able to modify it later. For this, the best solution is to directly create a new material slot through our good old modeling mod. Once again. Once that's done, don't forget to specify this new slot during any new fracture generation to avoid any surprises. And before creating our famous fracture, also remember to check the scale and rotation of the mesh in the scene. Indeed, we need to apply an equivalent of freeze transform like we have in Maya, for example. We must ensure there's no extra data on these transforms. Modeling Mod will once again be your best friend. And now we are ready to set up our first fracture, creating a new asset, a Geo collection. I'll be testing different setups here, making sure to think and anticipate as much as possible. As mentioned earlier, don't forget to assign the correct material slots so we can assign a different material to the inside of the Geo collection. I also created supports by duplicating the original mesh here, so that the debris has something to rest on after the destruction. You can disable debug mode here by turning off show bounce color in the details panel. We'll run several tests and I'm going to adjust the damage threshold to modify the behavior of the fracture. Lowering these values will reduce the retention forces between clusters and bones of each fracture. Our geometry will become more sensitive to the fracture, although this still depends on its shape, and as you can see here, I had to rotate the rod to see the fracture reaction. Its geometry doesn't favor spontaneous fracture. It's all flat and compact, solid as a rock. After assigning a temporary material to ensure it works correctly, I head back to Bridge and find a more permanent material to apply. The fractures are still pretty rough here, which is why I continue breaking everything, focusing specifically on the central line, simulating, for example, the path and firing line of our mech. To manage my fracture properly and generate it, aside from using gravity, I call on specific actors for this fracture mod, namely anchor fields, bomb field, and master fields, found in the engine content. I'll first place 2 anchor fields on my rod, which will block and prevent any fractures in this area. Don't forget to reference them in your Geo collection via the initializations field attributes, otherwise they won't do anything. For the master field, which I'm using first here, there's no need to reference anything. Just placing and overlapping this actor with our geometry will trigger the fracture. We have additional settings available in its details panel if needed. It's starting to take shape. To get a different perspective on how my fractures behaves, I'm now going to use the bomb field actor to manually control everything. No need for the master field anymore, although you can use both together if you want. Here, I need to readjust the damage threshold I modified earlier to increase and restore the initial retention strength of the clusters, thus avoiding a fracture that's too sudden and uniform. Okay, we're breaking things, but it still feels a bit flat overall, right? If we want a more realistic explosion, we expect an explosion path with more pronounced debris projections. We can fix this by activating an attribute on our bomb field, the bomb attribute. Quite straightforward. After a few more tweaks, I'm getting closer to what I had in mind. As you can see, the broken blocks here still looks pretty sharp and rough. It's not quite realistic yet. A super cool feature available in Fracture mode is the embed geometry. With this, we can parent additional props and debris to each cluster in our Geo collection. It's fairly easy to set up, and it can add a lot to your simulation. To start, just grab some debris from Bridge. What I'm going to do next is check the overall scale in relation to our road and create a sort of prefab by duplicating the same debris several times. Once I'm satisfied, I just use the merge function to create a single static mesh. This will also reset our transforms, which is actually a good thing.
But won't it be complicated to set up these debris?
Not at all, you'll see. Setting up our embedded geometry is quite simple. You just place them where you want, inside our Geo collection, and then go straight to Fracture mode. Make sure to select all your debris as well as your Geo collection with all its clusters, then using the auto function under embed. The job is done, and yes, it's that easy. You'll notice that the individual static meshes remain in your scene and outliner, but you can delete them without any issues. Everything is saved inside the Geo collection. You can even check out and count all your embedded meshes in the Geo collections editor. And if we run a little test, we'll quickly see the results. We'll fine-tune everything later, of course. If you ever want to remove the embedded geometry, the Flush tool will be your best friend, with the added functionality of recovering everything as a single static mesh. I'm going to take it even further by repeating the debris creation process I just showed you. I grabbed more props from Bridge, adjusted them, duplicated, and merged them to have a unique actor. I even went back to modeling mode to create a layer of old stone road with a displacement map that I got from a Bridge material again. I checked out several references to create a more realistic underlayer for the world. So using modeling mode, I tried to create less repetitive shapes, partially using booleans. Well, I think we've got enough variation here. Let's keep going. Now it's time to be patient and get to work. I place all my embedded geometry starting with the edges to see how it looks. It's coming together nicely and I continue working on the edges where the anchors field end. I keep going like this, as you've guessed, creating variations and less clean breaks. I think fracturing the rod horizontally rather than only vertically would have helped break up the repetitive look even more. I'm still not completely satisfied, so I thought we need to add more details to the materials. Specifically, I want to add cracks that I'll animate to appear during the explosion shots, along with a small color layer inside the rod to add even more detail and randomness. By using a gradient based on world position offsets, I figured this could help reduce the harsh transition between the outer and inner material colors. For the cracks on the world, I used a mask that I created on Canva. Yes, Canva, you heard it right. Why not? Everything's possible here, we're experimenting with everything. I then set up a material with a simple lerp logic and adjusted intensity via parameters. I also added a tiling system to control the crack size. The normal from height map node allowed me to use the same black and white mask texture and convert it from a bump map to a classic normal map. This was really useful to emphasize the cracks and their depth. Later, I animate the appearance directly in the sequencer. You'll see. Next, I felt like something was missing underneath the rod. It felt a bit empty, which wasn't great. So I decided to add a pipe and some dirt edges below. Back to our good old bridge, and off I went shopping for pipes. I pressed them properly and then merged everything to create a single geo collection, ready to be fractured. I repeated the same steps as I did for the road, creating fractures and more fractures and fractures. I started with a slice to cut the pipe in the middle and then added additional fractures. I also used extra anchor fills to further adjust the fracture behavior in general. After that, I refined the underside with additional meshes as I mentioned earlier. I duplicated, arranged and tweaked the material a bit. After some patience, it really started to come together. It's a long process to think through because there are quite a lot of elements involved. To finalize and take the details of our simulation even further, we're going to use Niagara, with what are called chaos datas. These will allow us to generate additional small debris, smoke trails parented to fractured pieces, and create various notify events. You'll see, it's definitely worth focusing on this part. First, let's make sure that collision data, break data, and training data are enabled in the project settings. These names are self-explanatory, as the latest generate and spawn any Niagara system based on fracture collisions, the initial break, or trailing of fracture elements. Next, we need to activate the notify events on the geo collection present in our scene. You found them in its details panel. And all of these features are functional and available thanks to the Kairos Niagara plugin, which is still in development. Now let's create an empty Niagara system that will adjust step by step. To communicate between the fracture and the Niagara system, we need a data interface, configurable within the Niagara system. Using a user parameter, we'll be able to generate various effects upon break, collision, or trailing. I start by creating a user parameter of the type Kairos diffusion data in our system. This is the main parameter we'll configure to achieve different effects in the Niagara system, based on its initial data source. To test that everything is working correctly, I begin by creating a simple particle emitter. The essential modules here are spawn from chaos and apply chaos data. In the spawn from chaos, I directly reference our freshly created user parameter to properly connect everything. Same goes for the apply chaos data module. I slightly change the color to make it even more debug, and let's see what we have now. I place my Niagara system in my scene, and it's beautiful. To test it further, I add additional forces like gravity and a collision module. I also tweak a lot of parameters of my user parameter directly in the details panel of my geo collection. Finally, I start to get a promising results. Now that we have the logic down, we just have to replace the debug emitter with emitters containing debris, for example, to create additional small debris that generate upon the impact and fracture of my geo collection, along with the initial fracture. And these will add even more detailed goodness. So, I use a mesh renderer and debris found on bridge. I adjust the overall size, its behavior in terms of collision, and most importantly, via its user parameter in the data interface. I continue the logic with other emitters using different debris within the same Niagara system, taking care to create data interfaces for each new emitter. This brings even more variation. And it's looking cuter and cuter, don't you think? For the smoke trail, I kept it simple and optimized, using sprites and textures with UV animations. It's simpler than fluids, more controllable, and much more optimized in the end. After numerous tests, I finally achieved a satisfying result with a small puff of smoke triggered at the right moment, dynamically and based on our fracture, of course. I keep fine-tuning everything from the color of the smoke sprites to adding more fractures along the way, to refine and detail it further. And I also refine and reposition my anchor fields, which play a major role in the overall fracture behavior. I try to avoid having them hold back my fracture too much during the general animation. I keep adjusting everything and it's taking time, right? But I'm liking the result more and more. So cool. Afterward, I tried adding a VDB to perfect the smoke and explosions caused by the mech after it fires. I went to Unbogen site to download a free example, and I ran several tests, but in the end, as you'll see, I didn't use it. Now let's focus on the scene itself, because right now it's still looking pretty bland. I picked up some assets that I've had for a while, and also from Epic City Sample Pack, which was used for the Matrix demo back in the day. I did some classic set dressing and layouts, focusing on the area where the action takes place, of course. I also used some free trees from Megascans. By the way, speaking of the City Sample Pack, the construction of the asset is quite well done, notably using blueprint-packed actors. I finalized this scene setup by adjusting everything in relation to a camera, to limit my work outside of it and avoid adding tons of assets that won't even be visible in the end. I then animated the mech to create a firing animation. Starting from an idle animation sequence, I fully took advantage of its control ray to adjust the pose and the final animation. Quick and fun to make, as always. We've got the animation, now we need to add some detail. Let's start by adding the projectile or bullet, if you will, which will obviously come out of the cannon. After downloading a model from Sketch5, I imported it and make a few adjustments, particularly to its materials. I then placed it in my scene and started animating everything in Sequencer. That's where I struggled to get the VDB from earlier to work the way I wanted. It turns out it's not yet fully functional for being animated and controlled anteriorly through the sequencer. In the end, as we'll see shortly, I fine-tuned my effects directly in Unreal via Niagara. I then thought I would use a Chaos Cache Manager to record and more easily manipulate my simulation. It's functional in terms of animation, but I encountered another issue that I haven't yet resolved. Indeed, if we use the Chaos Cache Manager here, our simulation is saved, but we lose the notified breaks, collision effects, and trails. And that's not great. That's why, in the end, I won't be using this method, but instead I play the sequence and a PI, play in editor, simultaneously. So I added and started playing with Niagara fluids, particularly to create the explosion effect during the shots, and some flames that could burst from the cannon. In the end, as I mentioned earlier, it's much more manageable to handle in the sequencer afterward, since you really have control with Niagara. For example, you can increase the resolution of the fluid and simply cache the simulation directly in the sequencer, thus avoiding having to read the simulation at runtime every time. More control and detail. Cool, right? I also added additional effects for the bullet ejection and kept fine-tuning everything during many new tests.
Hey Stefan, did you start from scratch for each Niagara fluids?
Actually, I relied on presets that are already available. They're well made and honestly, you have more than enough to create what you want with them. Don't hesitate to try them out. Next, I placed the camera to get a clearer view of the final result and continue to blow everything up over and over again, because it's fun, of course, and to adjust the whole shot. Finally, as I mentioned earlier, I didn't use the Chaos Cache because my notify events weren't triggering. So I animated the movement of my bone field in the sequencer, and to really preview the results, I launched a PI and then my sequencer. This workflow is similar to what we'll have during a render because don't forget, During a render, the simulation visible through a pie is also triggered. It works, but the only thing to remember is that you always get a different result. At the end, nothing is cached. So it works pretty well, I think. I kept adjusting my shot using the sequencer and tweaking various settings inside it. I also, as I mentioned, adjusted the animation of the road cracks by playing with the parameters exposed through my master material. I kept refining everything, and here's the final result. By staying entirely within Unreal, we've managed to achieve a pretty realistic destruction shot, in my opinion, while fully leveraging Unreal's potential. From the fracture mode to the Tata interface, with the connection between the fractures and our Niagara systems. We even added Niagara fleets to further detail the shot fired by our mech. Doesn't this make you want to create even more apocalyptic scenes? Thanks for watching this video, guys, and for your continued support. You are the best community. See you next week for a new video. Ciao!